So here's the walkthrough for the Chapter 1 practice test. And hopefully you'll find this a little bit helpful. This should be a review of everything that we've covered this chapter. So, first thing we did, find the distance between -4, -3, and 6 and 4. So, just as a reminder, the distance formula is the difference of the x's squared. So, often we write this, x2 minus x1 squared, plus the difference in the y squared. So, we go to our x's. Square root. We have 6 minus a -4, which is plus squared, plus 4 minus a -3 squared. So if I work that out, this is 10 squared and this is 7 squared. So that gives us the square root of 149. Now, just as a quick check, I can see if this is a number that's divisible, not divisible by 2, divisible by 3. If I add these up, that would be 13, 14. No. So I'm going to leave my answer as the distance equals the square root of 149. Next up, find the midpoint between 2, 3 and 12, 5. So the midpoint is the average between 2 points. So even if you forget the formula, as long as you can find the average between 2 points, then you should be good. If not, the formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And if you don't give me your answer as an ordered pair, you will be losing points on the test. So that's just a heads up. So then, for our values, we're going to have 2 plus 12 over 2, comma, 3 plus 5 over 2. So our midpoint will be 14 over 2, which is 7. 3 plus 5 over 2, which is 8 divided by 2, which is 4. So that's my midpoint. Next up, graph an equation by plotting points. Show work for at least 3 of them. So we want our graph here, and then I'm going to make up a table for us, x and y. I'm going to label our graph x and y. So normally I would look at points that are close to the origin. If I plug in 0, for example, if I plug in 0 here, I'm going to get 0 plus 4 cubed. 4 cubed is 64 minus 5. 64 minus 5 is 59. That's a point that doesn't really help me that much. So I'm going to look for what makes this number 0, because that's going to be a lot more helpful. So if we look at what makes this 0 on the inside, that should be -4. So I think an interesting point will be -4, because when I plug in -4 here, I get -4 plus 4, which is 0 cubed, minus 5. So at -4, I get -5. 2, 3, 4. 1, 2, 3, 4, 5. So that's one of my points. Next up, I'm going to look one more to the right of -4. How about -3? If I plug in -3, I get -1 cubed. So -3 plus 4 is 1 cubed. So that's 1 cubed minus 5, which is equal to -4. So I only go up 1 over 1. Likewise, if I chose -5, I'll get -1 minus 5, which would give me -6. So if I just extend my graph a little here, and the shape that I'm going to get is going to be an x cubed graph. That will look something like this. Now, if we recall, and we wanted to check for y-intercepts, to find the y-intercept, you plug in 0 for x. So if I plug in 0 for x, I get my y-intercept of 59. So my graph is not quite to scale. It should be more going up like that, really, really fast. Moving on. Number 4, find the intercepts of x minus 2 squared plus y equals 16. So for x-intercepts, plug in 0 for y, right? So let's plug in 0 for y. Now that leaves me with x minus 2 squared equals 16. I'm not going to FOIL this out because I'm going to take the square root of both sides. Knowing that I take the square root of both sides, I'm going to be left with plus or minus 4. So then I'm left with x minus 2 equals 4, x minus 2 equals negative 4. So my solution is going to be x equals 6 or x equals negative 2. And the ordered pairs that I get from there, I'll write those in a different color, is going to be 6, 0 and negative 2, 0. So for y-intercepts, just like we did above, for y-intercepts, plug in 0 for x and solve. So in our case, if I plug in 0 for x, I'm going to get 0 minus 2 squared plus y equals 16. Well, negative 2 squared is 4 plus y equals 16, so y equals 12. So my y-intercept, if I write that as an ordered pair, is 0, 12. 2 more on this page. Write the slope-intercept form of the line with the slope 5 containing the point 2, 2. So I'm going to start the easiest way. Slope-intercept form, that is y equals mx plus b. I have a point and a slope, so I'm going to use point-slope form to start. Point-slope form is y minus y1 equals m times x minus x1. So let's fill that in. I have y minus a negative 2 equals, the slope's 5, x minus 2. Now all I have to do is a little bit of algebra to get it in this form. So I'm going to first distribute that 5. I'm going to write that over here. So I have y plus 2 equals 5x minus 10. Then I'm going to subtract the 2. So I get y equals 5x minus 12. That's in slope-intercept form. It took me all of 1, 2, 3 steps. So pretty straightforward. Last one on this page. Write the general form of a circle with center 5, 12 and radius 13. General form of a circle looks like x minus h squared plus y minus k squared equals the radius squared. We have all that information given to us, so we can just plug that right in. So it would be x minus 5 squared plus y minus 12 squared equals 13 squared, which is 169. So I write 169 right there. So that takes care of the first page. Moving to the second page, we're on number 7 right now. So find the general form of the circle, then identify the center and the radius. This is not in standard form yet, so what I'm going to do is put it in standard form. Standard form looks just like we did the previous page, x minus h squared, y minus k squared equals r squared. So the first step is I'm going to add 17, and I'm going to group the x terms and the y terms together. So I have x squared plus 6x, and I'm going to leave a little space, plus y squared minus 4y, I'm going to leave a little space, equals 17. Half of 6 and squared, because we're going to do complete the square, so half of 6 squared is 9. Whatever I do to one side, I'm going to do to the other. So plus 9. Same thing on the inside. Half of negative 4 is negative 2. Squared is 4. So I'm going to add 4 to this other side. So if I did all of that right, I'm going to get, this is a perfect square, which is x plus 3 squared plus y minus 2 squared. That's another perfect square. My half negative b goes right there, equals 17 plus 9 plus 4. 9 plus 4 is 13. 13 plus 17 is 30. So my center here would be at negative 3, because it's the opposite, comma 2. And my radius, if r squared equals 30, then r equals the square root of 30. And just to know that we can't simplify that anymore, 30 is 6 times 5, or 2 times 3 times 5. So my radius is the square root of 30. A few more, and then we'll be done. For the line 4x minus 6y equals 12, the line parallel to it would have the slope blank. So parallel means same slope, and perpendicular, which is the next line, that means opposite reciprocal slopes. So I need to find out what the slope is here. The easiest way to do that is to put it in slope-intercept form, which is y equals mx plus b. So taking this equation, I'm going to first subtract. What I'm going to do is I'm going to do a little flip-flop. So I have 4x minus 12 equals 6y, because I like to work with positive things. Then I'm going to divide everything through by 6. So divide by 6, divide by 6, divide by 6. So that leaves me with y equals 2/3 x minus 2. So now I can easily fill this in. For my parallel slope, it's going to be 2/3. For my perpendicular slope, it's going to be the opposite reciprocal, so negative 3 halves. Couple more. Find the equation on the line with a slope that is undefined through the points 4, 3. Undefined slope means vertical lines. And vertical lines means x equals equations. So we look here for our ordered pair. My x value is 4. So to write the equation of the line, it's just x equals 4. So then we look at the next one. Find the equation of the vertical line through the point 2, 6. Well, it's the exact same question. Undefined slope or vertical line, x equals 2. If this word was horizontal, just as a note, horizontal lines, their slope is 0, and we write their equations, y equals some number. So this is another good thing to keep in mind when you're doing these problems. Last up, is the following function symmetric about the x-axis, y-axis, and origin? So to figure out if something is symmetric about the x-axis, we plug in a negative y. So I have x minus negative y squared equals 6. Well, this squared just makes it positive, which gives me the original. So it is symmetric about the x-axis. To check for symmetric about the y-axis, I'm going to plug in a negative x to my equation, and I can see that a negative x is going to change this equation. So it's not symmetric about the y-axis. Likewise, I could check the origin, which is plugging in a negative to both, and I can still see that I only have one sign change still, that negative x. So this doesn't work because I'm going to be left with negative x minus y squared equals 6. So this is not. So that's the practice test. It shouldn't take that long for you guys to do, and it should be a pretty good example of your test that's coming up on Friday. All right, good luck working on this.